provide. I'm a civil engineer with the State Department of Transportation, and I am working with Green Infrastructure team. I'm going to hand it over to Travis.
Good morning, everyone. My name is Travis Ostrom. So I'm with the Center for Watershed Protection, and we're going to be doing this training with the Department of Energy Environment and with DDOT, just going over some of the important things to consider when talking about stormwater management in the public right-of-way. We've done this presentation before once this year, and we've done it in years past. And so hopefully this will help you get an understanding of what considerations you need to think about when preparing a project that has some public right-of-way component to it. Do you want to introduce anyone else? I don't know if anyone wants Melifon or anybody else from DOEE wants to say anything before we get into it.
Sure. Good morning, everyone. My name is Melifon Parandush. I'm a plan reviewer at Department of Energy and Environment. I won't be presenting this training. Travis is going to take care of it for me, and I will cover if I am needed. Yeah, I hope you enjoy the training.
Excellent. All right. Well, thank you. So we have also didn't mention my colleague Greg Hoffman, who's also with Center for Watershed Protection, may be available later for the question portion. So we're going to leave questions towards the end. We have a little section in the middle. But as Morvari mentioned, please put any questions in the chat. You can do it throughout as I'm giving this presentation. Feel free to throw things in the chat, and then when we get to the point where we'll pause and respond to the questions. So feel free to throw them in there at any time, and then we'll address them when there's a good breaking point there. So let me go ahead and share the agenda for today. So we're basically going to go over an introduction to the stormwater management in the public right-of-way. I'm going to take my camera off here also because I'm just going to be looking to the side, so that's not so interesting. And then I can also see your chat stuff as well. Okay, so the stormwater management in the public right-of-way, we're going to be going over the MEP philosophy, that's the maximum extent practicable. So what that philosophy is, the policies around it, looking at some of the ways that works in the public right-of-way, so looking at conflicts for when you're trying to put in best management practices or BMPs. And then we're going to look at the two different types of MEP projects. So there's the maximum extent practicable that we consider in two different scenarios. And then we're going to go through just briefly, some of the submittal challenges that we get when you're submitting a plan to the surface and groundwater system, which is DOEE's sort of system for interacting and managing these plan submittals. There's also an activity. So at the end, I'm going to actually ask you to pretend like you're a plan reviewer or a senior engineer looking at a design plan, and go through and just identify some of the challenges, some of the items that are missed or could be different, and just make your comments on those. And then Morvari is going to come back in on the end, and she's going to give some specific guidance to DDOT, because remember, this is a DOEE regulation, the stormwater management regulation, but it's specific to the public right-of-way, which is DDOT's realm. So there are sort of specific adaptations of the guidance that DDOT can guide you on. So we're going to get a good look at that later on, and there will be breaks throughout. So the schedule for the training is till 12:30. We probably won't go that long. Depending, we could go that long. So feel free to ask any questions. Don't hesitate, because we can take the time if we need it. But we'll have some breaks through, so you won't be sitting here for 3 straight hours. Don't worry. So let's get into the public right-of-way stormwater management. So when we're looking at the public right-of-way, you're doing some reconstruction in an existing public right-of-way. So we're talking about roadways that exist, this adjacent sidewalk next to a development parcel. There's sort of two situations that we differentiate. So one is the type 1 public right-of-way project. So this is when there's a roadway reconstruction. So you're doing sort of a linear project, doing a sidewalk, trails, alleys, roads, any of these sort of projects that generally this will be a DC government, federal project possibly. And this is where you're really looking at the roadway and that's your project, right? And then you're maybe doing some work on the adjacent sidewalks. A type 2 project is a private development. So this happens all the time. You're developing a parcel and there's some associated adjacent public right-of-way that's disturbed or developed as part of that project, right? So you might have a commercial building, and then there might be the adjacent sidewalk out front or the alleyway that gets redeveloped along with that. And so that's a type 2 project where the public right-of-way work is sort of incidental or associated with a development of a private parcel. And we'll get into the differences and how those are handled in depth later on in the presentation. So there are a few cases where the public right-of-way stormwater management regulations do not apply, some exemptions to this application. And so one is when there is a major regulated project that does not disturb the adjacent public right-of-way. Right, so just because you're developing a private parcel, you don't always disturb the adjacent public right-of-way. Sometimes your disturbance is limited to these, I'm skipping to the bottom here, but sometimes it's limited to these activities that are mentioned here. So just trenching for utility work, right? So if you're not really redeveloping the public right-of-way, you just have to put in a trench for the utilities. Stormwater management regulations don't apply to that. Aprons, so driveway aprons are also another case, or minor disturbance, which I believe is less than 50 square feet. But there's, very little disturbance happening in the public right-of-way. So these cases, you don't have to do a full stormwater management plan for the public right-of-way. It's just what you're doing on your private parcel. And then there's the example of, or the case of voluntary retrofits of the existing public right-of-way. So this is where you'll be voluntarily retrofitting the public right-of-way to achieve better stormwater management. So putting in a bioretention in the public right-of-way, putting in a permeable pavement in the public right-of-way. These types of projects, when it's voluntarily just, the intention of the project is the BMP itself, then the public right-of-way maximum extent practicable process that we're talking about today doesn't apply. There are still some regulations around that, some design specifications that you have to follow, but this process that we're going to talk about in depth today doesn't apply to those voluntary projects. So when we're going over the stormwater management regulations, there's a regulated stormwater volume that you have to manage. So it's based on the limits of disturbance, right? And so the default is that you manage that volume. So in the public right-of-way, we regulate it at the 1.2 inch stormwater event, right, or storm event. And so if you were going to meet that full regulatory volume, you would calculate, how much disturbance you have and what volume that equates to based on the 1.2 inch event. And we go over that in another training that's available online, the general compliance training. So if you haven't watched that, please go ahead and do that. That'll give you the basics of a lot of that, but I'm not going to cover that too much here. But essentially that's your sort of target. And you don't have to use the maximum extent practicable process. You can just actually treat and manage that 1.2 inch event over the full limits of disturbance. You can also over control in some areas. So for example, you have one drainage area that you just can't fit a BMP in, and another drainage area where you can over control. You can get some roadway runoff that's outside of your limits of disturbance. Then you can compensate for those, right? It sort of balances out between the two different areas. But you have to maintain a minimum of a 0.6 inch event in each of the drainage areas. But that's another option. So you try to reach that still the same volume target, but do it by sort of differing levels in the different areas. You can also manage the minimum of the 0.6 inch event within each drainage area and then balance the rest through offsite retention. This is rarely used because it's not required, really, right? So you're doing the maximum extent practicable process in lieu of paying for some offsite retention volume. I don't think I've ever seen anybody do this, but it's an option. If you want to pay for those offsite retention volume credits, you absolutely can. And so this last one is really the bulk of what we see in the public right-of-way. And it's to establish a technical basis to demonstrate that stormwater management has been met to the maximum extent practicable, or the MEP. And so that's what we're talking about today, is really doing everything that you can in the public right-of-way, considering the conflicts and the whatever else is going on in the public right-of-way that you have to work around, to get us close to that full volume that started with the first bullet point there. And then that's really kind of the most common thing. But it's important to remember that the target is always that the full retention volume. So don't undersell yourself. There are opportunities to do stormwater management in the public right-of-way. So please keep that as a focus throughout this, is that we're going to look at a lot of different, conflicts and different reasons why it's difficult to do stormwater management in the public right-of-way. But it's a good thing to keep in mind, is that we are trying to keep that goal in mind, that maximum extent in mind. So that said, really the maximum extent practicable, or the MEP process, is a recognition that it's technically infeasible in many cases to achieve that full regulated retention volume, right? So you go through this process and you demonstrate how you've done the stormwater management to the MEP, right? And as I mentioned from that third bullet point, it's excluded from the requirement to use offsite retention. So you don't actually have to. You're absolutely welcome to purchase offsite retention credits through the SRC trading program, but you're not required to. Sorry, I lost my slide. So talking about some of the constraints in the public right-of-way, there are unique site constraints for each site. So each site's a little bit different, but generally we have some of the same, in many cases, some of the same conflicts. And one is that there's limited space outside of the roadway, right? So the main part of the public right-of-way in most cases is the roadway itself. So working around that area sort of between the roadway and the private parcels restricts a bit of the opportunity for stormwater retention. Often, especially for these type 2 projects where it's really disturbance of the public right-of-way ancillary to the primary goal of the project, which is the private parcel, you're really not going to be modifying the roadway, right? Some of those roadway reconstruction, the type 1, possibly can do some more modifications to the roadway, but in general, the roadway is the roadway. So you're kind of working around that as a major constraint. And then there the traffic loads again. So that's sort of the roadway kind of takes primacy of, that's the primary use of that space in most cases. So one point that I want to really emphasize here is that these regulations are driven by the Department of Energy and Environment, the DOEE standards. And so we have this Stormwater Management Guidebook, last updated in January 2020. This is available on the DOE website. I highly recommend everyone, if you haven't, read through this and get familiar. And that other training, I think it looked like someone posted it in the chat, the link to the other trainings on YouTube for the compliance. So that goes over a lot more in detail on the Stormwater Management Guidebook. But that's a really good thing to remember here, is that we're talking about public right-of-way. It's sort of a specific instance of the stormwater management that's covered in the Stormwater Management Guidebook. And we're going to go talk about the BMPs, or talk about this public right-of-way MEP process. And it ends up kind of focusing on 3 primary BMPs, not exclusively, but just because of the constraints, these end up being the 3 most common, right? Where we have permeable pavement opportunities. Bioretention is a really big one because you can fit a bioretention in a relatively small space to get a relatively large treatment volume or drainage area, right? It kind of gives you a lot of bang for your buck when you're talking about this constrained real estate of the public right-of-way. And then tree planting and preservation, this is a huge opportunity. DC has some very ambitious goals on preserving and increasing the canopy cover of trees throughout the city. So it's really important to recognize that BMP as one that can be taken advantage of in this MEP process. So to go into that into some detail, we have a specific standard here. This is for a bioretention with a tree pit and an adjacent structural soil. Right, so this is one example of how you can use that space really efficiently and effectively. So you have sort of 3 things going on here. You have the bioretention, as you can see on the right, sort of a picture of a curb inlet from the roadway. So it's receiving runoff from the roadway, letting that runoff, that specially, polluted runoff, come into the bioretention. The bioretention does its thing. It does the ponding, it does the filtration, it removes the pollutants, it retains the volume of the stormwater. Generally, as you can see down there on the detail cross section, there's a perforated underdrain at the bottom of these, typically because one of the constraints in the public right-of-way is a high level of compaction, so not great infiltration in many cases. But in most cases, in many cases, there is a storm sewer available somewhere that you can connect an underdrain into. All right, so you've got that bioretention function there. And then you also have the tree, right? So the tree is in the bioretention area. So the tree can be an additional BMP on top of the bioretention, right? So when you're doing your calculations for your retention, you get credit for the bioretention itself, and you get credit for a tree that you're planting. Right? So the tree has all sorts of functions. It's got the canopy, it's got the interception of stormwater, as well as the co-benefits that you get from both bioretention and trees in terms of the urban environment and all of the ecological and heat island and the other benefits you have to putting in these plants in these areas. And then the third component of this that I want to point out is shown on the left side of this detail cross section here, where you see this compacted media at 10% porosity. Right, so this is an opportunity where you can put in some structural soil, and there are different ways to do this. There are geosynthetics that can support the pavement, and then you put in an uncompacted soil underneath, or you can use like a structural soil that has a higher content of stone. And this is a way of basically putting in more storage volume, more rootable storage volume, I should add, into the area adjacent to the bioretention, right? So you still have to maintain that sidewalk area because it's a public right-of-way. That's one of the uses of the public right-of-way. So you're maintaining that sidewalk, but then you're also providing additional storage underneath that sidewalk, which increases the stormwater retention value that you get out of this bioretention. And then it increases the ability for that tree to thrive, right? It increases from what would be a pretty small area otherwise for this tree to root out and spread its root network. You can actually allow it to spread underneath the pavement and access some of that moisture that's stored underneath in that media. All right, so there's 3 elements to this, and it's just, I point this out and go and spend a lot of time on it because this is the kind of thinking that we want to have when we're thinking about stormwater management in the public right-of-way. It's using what's there. It's using the access to the adjacent roadway runoff. It's using the volume underneath a pavement. It's using the space where the bioretention is as a tree planter, in addition to what you would normally have in a typical streetscape of just having tree planters. So it's integrating all these elements together to use this space really effectively and efficiently to get a maximum stormwater management value out of it. So all that going into the detail in the DOEE Stormwater Management Guidebook, we need to point out that there are also specific DDOT standards, right, specific to the public right-of-way. The standards are consistent. The DDOT standards are just sort of a distilled and a targeted application of the DOEE Stormwater Management Standards. So they've really done some work to take that general guidance from the DOEE standards and put them into this public right-of-way specific green infrastructure standards. So take a look at these green infrastructure standards from DDOT, and you'll see that there are specific details in there for like what I was just showing of that tree pit, bioretention, structural soil. So they've done a lot of work to adapt and apply those DOEE standards to the public right-of-way context. Here's an example looking similar to what we were just looking at before, where you have this bioretention planter adjacent to the roadway, right? And the standards are consistent, but they go in a little bit more detail here in the DDOT specific to this context where they're identifying the sidewalk and the roadway and how they should all interact and where the curb cuts can go. So going into this public right-of-way maximum extent practicable sort of philosophy and policy, the basic principles of the public right-of-way MEP are starting from is maximizing BMP placement, right? We want to use as much of the space available to put BMPs in as possible. We also want to maximize the BMP sizing. So where it makes sense, where you're actually getting drainage area going to these BMPs, getting as much retention of that drainage area, right? Maximizing BMP sizing, I don't mean putting in a gigantic bioretention that only has a tiny amount of area draining to it. That's not useful and effective, but maximizing in terms of the BMP sizing relative to its drainage area. So getting as much stormwater treatment as you can. Minimizing impervious widths. This is an important point that I think is oftentimes overlooked. We want to try to not just put in BMPs, but also just see what we can do to minimize how much imperviousness is in the public right-of-way, right? Are there areas that you can remove an existing pavement, maybe extend the tree rootable area that's there? Are there other uses? I'll go over some examples here, but are there other places where you can use, instead of a permeable or an impermeable surface, can you change it to a permeable surface? And then managing the commingled stormwater runoff. So I mentioned this when I was talking about the detail of the bioretention adjacent to the roadway, is it's a great opportunity to treat some of the roadway runoff that's coming off of this. It's got a lot of the pollutants that the cars are putting on the roadway, and so even though what we're talking about is the public right-of-way disturbance that you may be dealing with, so on a type 2 project you probably aren't redeveloping the roadway itself, but you may be developing an area where you can put in a best management practice that can receive some of that roadway runoff, right? So just because it's outside of your disturbance area, it doesn't mean that it's outside of your scope, right? So you can really keep that in mind as one of the principles of the MEP, that we want to be able to look for where we can get this roadway runoff that's adjacent to our project. So walking through the process, here are the basic steps, sort of outlining. And it's broken into a bunch of steps here, but basically I want everyone to take a step back and just think about what it is, what the MEP process means overall. And it's basically, you know, looking at your situation, identifying constraints, and putting in BMPs everywhere you can. That's sort of the basic, you know, philosophy behind it. Right, so the specific steps to that are going to be first starting at the target, right? What is our target stormwater retention volume? And the swerve, it's calculated based on the stormwater management guidebook. It's just a function of how much area is being disturbed, and then that 1.2 inch storm precipitation depth. Right, so that's your target. That's where you're going to start. You want to know, all right, how much am I trying to retain? And then you go into how am I actually going to do that? All right, so you're looking first at your situation. Can you infiltrate? Right, maybe in the situation that I just showed, where it's just the space between the road and the sidewalk, you may not have great infiltration. But there are other situations where you have, a different available space, right? Maybe it wasn't an area that's always been used as sidewalk. Maybe there's a public right-of-way area that has actually good infiltration. So you have to consider it. You have to look at it, because that's really one of the best mechanisms that we have for reducing stormwater issues downstream of our work areas here, is to get that runoff infiltrated. Consider land conversions, right? So can you convert, as I mentioned, some of that pavement area into a turf area or a landscaped area? And then identify the optimum BMP placement, right? So before you start looking at all the constraints, you're just looking at what's the target that I'm going for, and in a perfect world, where would I put all these BMPs? What pavement can I get rid of? What landscape areas can I put in? How would I optimally put these BMPs in, all things equal? And then you're going to look at your conflicts. You're going to look at the existing infrastructure, right? Where are my storm sewers? Where are the other utilities? Maybe there's a gas line going through the middle. Maybe there's other BMPs nearby, right? What are these other existing infrastructure features that are there? And then looking at these sort of out of the box type opportunities, right? Looking at integrating traffic calming measures, right? You're looking at this public right of way as not just a way to manage stormwater or get cars through. You're looking at it as sort of a full streetscape with a lot of different purposes to it. So looking at how do you integrate the stormwater management BMPs into those uses. And as I mentioned, that commingling of the roadway runoff is an important consideration. And then it's a possibility and sometimes an opportunity to consider adjacent public lands. There are other considerations that go along with that, so I won't stress it too much. But then you're really going to be looking into the drainage profile and placing and sizing the BMPs, right? So once you've sort of looked at all these different, your target, your ideal placement, your conflicts, and your potential opportunities, you can look and put in those BMPs and then place them so that you're grabbing as much of the drainage area as you can, that you're getting this drainage profile sort of worked out based on your placement of the BMPs and what other things you're having going on in the public right of way. So the MEP process, it's a process for design, but it's also a process that you have to demonstrate. So you have to demonstrate to the plan reviewer that you've gone through this process and document the steps in the process that you've done. All right, so you want to demonstrate that you've evaluated the infiltration capacity. So looking at the water table elevations for any opportunities if you don't have water table issues, if you do have restrictions based on high water table. Looking at the infiltration feasibility. Right, so you have to do geotech testing, looking at is there a possibility to amend soils, under drains may be needed, and then looking at any soil contamination that may be present in the area. Right, so these are just things you need to look into when looking at the infiltration potential or limitation. Looking at existing infrastructure, right? Is there potential conflict of anything in the subsurface, right? In the public right-of-way especially, there are a lot of infrastructure in the subsurface, right? You have to identify the location and the elevation of the existing storm drainage infrastructure and really all the utility infrastructure. If you're going to demonstrate that you've done the maximum extent practicable, you have to show where these utility conflicts are and that they actually are a conflict, right? Just because there is another utility in the area doesn't mean a BMP isn't possible, right? Because the elevation could be important, the placement is important. The trees, existing trees is an important thing to note, right? There are areas available for additional tree planting, or there may be areas available to increase the soil volume of those existing trees, right? We never want to incentivize or encourage removing existing trees to put in a stormwater BMP, right? An existing tree is a great stormwater BMP. So if there's an existing tree, we want to preserve it. We want to maximize its longevity and success. So really, when there are existing trees, the goal of the public right-of-way project should be to work your design around preserving as many of those as possible, and where possible to increase the soil volume available to those trees. So when you get into sizing the BMPs and placing the BMPs, you want to delineate the full drainage area to the BMP locations. All right, so not just the BMPs, not just the drainage area that's within your LOD, within your limits of disturbance. You want to look at the full drainage profile of all of the roadway runoff. Maybe there's runoff coming from the private parcel that's getting to these BMPs. So you want to look at and delineate that full drainage area. And then follow the sizing and design methodology for whatever BMP it is, using the appropriate chapter of the stormwater management guidebook from DOEE and from DDOT. Right, there are the specific design and sizing methodologies in those documents that are very helpful. And then you provide that to the plan review, right? Provide the calculated sizing criteria for that BMP. And if you can't design the BMP exactly based on those criteria, there can be reasonable modifications to it given whatever constraints are there, right? We want to right size the BMP rather than oversizing the BMP. So as I mentioned, having a gigantic bioretention that's not receiving a lot of runoff isn't really that helpful. It would be preferable to have a right-sized bioretention and some additional green space rather than having an oversized bioretention that's not going to be doing much because it's not receiving enough for drainage area. So going into some of these conflicts in a little bit more detail, excuse me. One of the most common conflicts we see is low infiltration rate. As I mentioned, we're working in the public right-of-way where oftentimes the historical use of that area has been compacted roadway or sidewalk. You may not have the available spatial layout that you need for connecting to a storm sewer. Oftentimes you do, but sometimes you can't. The topography, right? Oftentimes where you're working, where you could put in a BMP is not where the water is going, right? Or where the water is going to go based on your design. So you can try to modify the design to some extent when you're reworking a whole roadway, but oftentimes the topography is sort of decided for you when you're working in the public right-of-way. You don't have, in many cases, the ability to modify that in the way you do if you're doing a full private parcel development or if you're doing a full roadway reconstruction. And then the existing trees, as I mentioned, is another common physical conflict. Beyond the actual physical conflicts, there are a number of other uses for the public right-of-way that we've alluded to throughout this, that there are all sorts of things going on in the public right-of-way, that it's not just a place to manage stormwater and get cars through. There are a lot of other requirements that we have to think about, right? Sidewalk widths, travel lane widths, pedestrian vehicle traffic volume, right? Not every roadway is the same. ADA requirements, right? American Disabilities Act, you have to have certain requirements for, especially at like street crossings, that sort of thing. Building entrance and exits, there are certain requirements based on what type of building, what the exit is, space that you may need to leave adjacent to a private building. Safety issues and view lines, right? You don't want to put a bunch of site constriction by planting right at the corner or in a way that's going to somehow create a safety issue from obstructing view lines. And then there are others throughout the DDOT standards and guidelines of these sort of multiple use of the same space to consider. Looking into just one example of the detail here for utilities. Utilities are one of the very common accepted conflicts, right? And when I say accepted, it's if you're demonstrating in this MEP process that you've considered, you're demonstrating, you're showing where on the plans, right? This is the sidewalk width that we have to maintain. These are where our utilities are placed, and this is the space, the spacing between where the BMP could go and where the utility is. As I mentioned, just because there's a utility there doesn't mean you can't do a bioretention or another BMP. There are details in the DOE Water Green Infrastructure Utility Protection Guidelines and other relevant agency standards that will determine whether you can put in BMP around those utilities. Right. So it's just a thing to consider. You have to look into it and demonstrate where these potential conflicts are. But if there are conflicts, it's a justification for not putting the BMP in that location. So there's just more kind of details on the setbacks. I won't go into too much detail on that, but just to point out that the setbacks are important to consider. So I've talked a bit more about the type 2 MEP projects so far. We're going to kind of go into a little bit more detail on that specifically. And it's a pretty straightforward approach, right? So you're looking at if the development meets the swerve in the public right of way. So that stormwater retention volume, that kind of target, you're looking, did you hit the target? Did you put in enough stormwater management features in the public right of way, right? Whether that be land conversion or a stormwater BMP to meet that full stormwater retention volume. And if not, has the designer maximized stormwater retention and provided a narrative, provided that documentation, that demonstration that the MEP has been followed, right? That's a really key part of this, is that oftentimes, I know there are a lot of things when you're designing that you go through and there are constraints that you consider. You have to demonstrate those to the plan reviewer, and that'll help you avoid some of the back and forth of the plan reviewer asking, oh, did you consider this? And maybe you did, but you didn't demonstrate it. So keeping that in mind when you're putting together your designs to make sure that you're communicating this process to the plan reviewer. So some of the common issues we see in these type 2, so this is the projects where it's the development parcel and the adjacent public right of way. We see plans that just don't consider the public right of way at all, right? There's some disturbance and just no attempt has been made or no attempt has been shown to put in any sort of stormwater management in the public right of way. An unclear delineation of the public right-of-way limits of disturbance. So there's oftentimes we'll see plans where the on-site, the private parcel delineation is very clear, but the work that's going on in the public right-of-way is not very clearly shown. So it's difficult to actually determine what area of disturbance we're talking about. A narrative, very essential to have that narrative explaining the MEP efforts, right? So, and the weak justification is something we see often. So we really want to have plans and designs come through that are showing this process, right? So the narrative is very helpful. you know, in a narrative form, explaining the efforts you've made to put in stormwater management to the maximum extent practicable. And you have to justify it, right? You have to consider all of the elements that I've talked about and justify why stormwater management. Oftentimes, I guess what these bullet points are getting at is that oftentimes the plans come through with sort of a sense that, you know, the public right of way was a bit out of, like, stormwater management in the public right of way was considered to be a bit out of scope of the project. That's not an acceptable justification, right? You have to consider it as part of your development project. If you're doing disturbance in the public right of way, just as you're disturbing the private area, you have to consider the stormwater management implications of that. So we'll have just a little pause here. We can go back through the chat and address some of the questions that have come through. We've gotten up to this part where we're talking about the MEP projects, and we'll talk about the type 1 as we come through this.
Travis, we try to respond, but I'm just gonna go over them.
Okay.
If still there is anything. Karen asked, I do trail project on federal land fall into SWM category 1 or 2. Are they exempt? We already responded that. I just want to know, Karen, do you need more clarification, or in the chat? Are you good? She didn't respond, but I don't know if you can see in the chat, we responded. If you want to add anything.
Yeah,
I think
I think that I'm not sure which the figure is, but that generally is right, that the trail projects have a special exemption that we haven't talked about here, the practicability process, which is sort of a specific exemption, and you can see in the DOEE Stormwater Management Guidebook in Chapter 2, there are some specific exemptions to the stormwater management, and so trails is one of them. There's others that are affordable housing, so a few other exemptions. So direct her to that Chapter 2 of the Stormwater Management Guide, the DOEE Stormwater Management Guidebook.
Yeah, she's also asking about figure 3 to 23. I think it's slide 9.
Slide 9.
Yeah. She is asking.
I can help.
Okay.
Yeah, I can help with this one. So just, you know, we've done this on St. Elizabeth. We've done this on a variety of capital improvement projects, because the question was like, where has this been applied? We've done this
guidebook figure
on retrofit projects. So we don't have this exact standard detail in the GI Green Infrastructure Standards, but we do have existing typical details that essentially combine 2 of our standard details to make this type of situation. And it does help maximize the amount of retention that you get for a certain facility.
Yeah, excellent. Thank you, Julie.
We also asked about we'll ask about the minor disturbance definition. Julie responded and checked the B444 DOE Stormwater Management Guidebook. Do you want to add anything? Well, Travis?
So what was the response to that one?
We refer B44 section of DOE Guidebook, Stormwater Management Guidebook. We didn't define if you want to add anything.
Okay. Yeah, no, I think that's right.
There was one question, is about the mill and overlay disturbance. We're going to go over the disturbance definition at the end by DDOT, but we also responded that in general, mill and overlay is not a disturbance. It's not considered as a disturbance. And we refer the Stormwater Management Guidebook section for it.
Yeah,
Julie, yeah.
Yeah, we generally consider, when we're talking about disturbance, the sort of disturbing the underlying soil, right? So if you're just doing the mill and overlay and you're not removing that base layer, then it's not considered disturbance. Absolutely. Anything else?
I think that's it.
Okay.
I know that we have also a practice. I'm going to share in the chat the materials that we have before we go to the practice.
Okay,
Travis.
perfect. Thank you.
No
Yeah, sorry, didn't get those to you earlier.
Sorry, before Will also asked, in general, if you're replacing a portion of asphalt with sidewalk, like curb bump outs, bus platforms, I think these are minor disturbance. Can you confirm?
So the minor disturbance would really relate to how much area. So sidewalk, that's disturbance. You know, it would be a matter of how much you're disturbing. So those, I guess I had to see. Let's see the exemptions slide.
Travis, I'll also jump in. This is Julie Pike.
Yeah, good thing.
Hello, I'm from DDOT Stormwater as well. It would not automatically just be considered minor disturbance. And we go over this a little bit more, like in the presentation that Morvard has. It's a little bit more specific in terms of what we're looking for. And so if your disturbance for, you know, a curb bump out or bus platform or anything else still triggers that 5,000 square feet, you would still have to look around and see what you could incorporate. They're just not automatically exempt. There is some construction, again, of these with the bump outs and the bus platforms in which a standard construction practice would not mean that you're removing like the GAB at the bottom, or you're not removing existing pavement layers, and those would not be considered disturbance. But I don't want anyone to think that we're encouraging you to leave substandard base in place just to avoid doing MEP. You know, this would be really based on like actual standard constructability and construction practices, not in an effort to like skirt around doing proper stormwater management.
Yeah, thank you, Joy. I think that's a really good important point to remember, is that like throughout certainly the DOE guidebook, I know very closely that there are all sorts of exemptions and special situations there, and that none of those are really intended to be, you know, to say, you know, you don't have to do any stormwater management just in general. It's really trying to recognize the specific cases. So there are some that are labeled in there, and there can be some case by case basis, but it's really, you know, we're trying to like point out some of these cases where, you know, we don't expect you to put a bioretention on top of a utility line that you've just excavated the trench for, right? So some of these kind of common sense situations where it doesn't make sense to apply these stormwater regulations, but it doesn't mean that it's really like we're trying to. We really don't want you to have your project or have in your mind, I'm going to do whatever I can to get around this, right? I'm going to modify my project to not trigger these, right? That's not the intent of any of these exemptions. The intent is really to start from a base point of you're doing what you need to do for your project and consider stormwater management along with that, right? So please don't have a viewpoint of, you know, looking for ways to get to minimize your scope by using the exemptions. Really just look at them the other way around of like, you know, these are known things that we are not going to ask you to put a bioretention in the middle of a driveway. These are, you know, or on top of a utility trench, that sort of thing. It's really kind of a philosophical, I guess, viewpoint that we're hoping that we can convey here. All right, so let me continue on with the.
Hey, Travis.
Yeah, go ahead.
There was just one more item about trails. Yeah, we referred to section 2.13 for trails, and so it can fall under the practicable process. And I don't know if you just want to dive into that, or you know, if they are natural cover, natural land cover, I think is a big issue with trails, and so.
Yeah. Okay. Yeah. So the trails is sort of a special case. So that's another one of those situations where it's, you know, a kind of a special situation where, you know, we're recognizing that there's possibly a trail that would have greater than the amount of disturbance that would trigger stormwater management requirements, but not in such a way that it makes sense to put in BMPs. And so that 2.13.2, I was just trying to pull up here, talks about the practicability process. And so that's a process where we really get into some of these special cases, like turf fields at schools or parks, trails, affordable housing, where you kind of, we're sort of recognizing the realities of those situations. So the athletic playing fields, for example, that's sort of a specific use of that land that you're not going to put in an athletic playing field with a bioretention right in the middle of it. So we allow for a certain design, and there are specifications for that. And then the trail disturbance. So if you're looking at a public park and you've got a trail going through it, that's one of the cases where you can use that practicability process. And if you have one of these projects, the best thing to do really is to reach out to DOEE and get a meeting with somebody and talk it out and have them help you work through your specific project, and they can tell you what applies and what doesn't in terms of these special cases.
I'll just add, sorry, just a little. Oh, Melifon, do you want to add anything?
Yes, sure. I can add to what Travis said. You can always schedule a PDRM within the surface and groundwater system and go over your projects before you submit to DOE for review. So if and determine if your project can be exempt or not. Sorry, Julie.
No, it's no problem. And then I was just going to add for natural cover. Natural cover is something. If you have an area that is mowed once a year, that would be compacted cover. That would be considered managed. So these are areas, if you're putting in a trail where there's just, it's completely vegetated and there's no mowing or there's no maintenance of it, that would be considered natural cover. So that also determines, if you have a park that is regularly mowed, a trail there is going to be treated very differently than if you're putting a new park on NPS land that is not being managed in any way.
Yeah, very good point. And the other point on that also for these trails is that the trails does not mean sidewalks adjacent to the roadway, right? So there's not there's a differentiation. We're really talking about a trail, not the sidewalk. So, is anything else? Any other questions you want to get to? We'll have more opportunity for questions later on as well. So maybe I'll go on to the Type 1 MEP projects. Oops. So we've gone over the Type 2, which is the private parcel and the adjacent public right-of-way that's disturbed as part of that development. The Type 1 is a slightly different situation in the public right-of-way, where you're really talking about redeveloping the roadway itself, right? And this is an existing public right-of-way, not a new roadway. So there's a different situation, and I think Morgan talks about that at the end. But if you're doing this project, you really have to approach it a little bit differently to what we were talking about for the Type 2 projects. And you want to really look at your project in the grand scale of it. So identifying these potential areas for land conversion and BMP location in and around the roadway, right? So traffic islands, triangle parks, median islands, paper streets, alleys, sidewalks, looking at these sort of efforts and opportunities to integrate BMPs with the other infrastructure and other spaces that are available in the roadway. So maybe with traffic calming measures, maybe in some of these median islands and that sort of thing, where you can use some of the space that's available for the stormwater management. And what you want to do is really demonstrate that you're giving full consideration to all these opportunities. You're focusing on commingling this stormwater runoff from the roadway and taking into account the full drainage areas, right? So just because you have this certain limits of disturbance, there may be additional runoff coming from areas outside of that limits of disturbance. So consider that runoff as potential to manage, right? So it it doesn't count towards that actual retention volume in the calculation. But if it is managed, it sort of accounts, it doesn't count towards the requirement, I should say. So when you're calculating the requirement, that target swerve that you're trying to achieve, that volume that's coming into your limits of disturbance doesn't count towards that. But if you manage it, it counts towards your credit, right? It counts towards your efforts to reach that swerve. Hopefully I got that across. So what you really want to do in these cases is you want to look for these opportunities for best management practices and for land conversion, right? You want to try to keep the imperviousness really as minimal as possible. You want to select areas for the optimum opportunities, right? So, you know, all things equal, where would you want to put the BMPs? Where would you want to put some permeable surfaces, just some landscaped areas, some turf that's going to achieve some infiltration? And then select the most appropriate BMP types for these areas using the guidance manuals available. If you can alter the drainage profile, so this is one thing that you might feel a bit constrained by the way the roadway is laid out. So kind of getting at integrating the stormwater management considerations into the project, that it's not just something that should always be an afterthought. It's something that can be worked into the project design from the beginning. And that may open up some opportunities for you by changing that drainage profile to allow for more runoff capture by the BMPs. And then again, with the land conversion, this is another thing. If you're considering stormwater management, you're considering this as an integral part of your project design, then you can look at some of those opportunities. Maybe it's on adjacent public land, maybe it's not. As I mentioned, with the adjacent public lands, there's some additional constraints that may come along with that. But there's often opportunities for land conversion and BMP designations that you can figure out if you're really thinking of it as an integral part of your project. So I'm going to walk through kind of an example. So the process here that is a little bit different than the narrative documentation process that we went over for the MEP Type 2. The Type 1 MEP has a kind of defined stages, right? You're going to be submitting your plans in the 30%, 65%, and 90% design stages and the 100%. So we really have to stress that we really want you to follow that process, right? If you come with a 90% design, and at that point you're starting to evaluate the stormwater management opportunities, it's going to make the whole process a lot more difficult, right? You really want to start at the 30%, like in your conceptual design. You really want to have this stormwater management integrated into your design thinking. And that's why we ask for the 30% submittal for the stormwater management plan, is then you can have it kind of integrated in and start thinking about some of these things. And there are specific steps to it. So we'll go through a little example here. So the first step, you're going to look at your drainage areas and your regulated volumes. Excuse me. So what's your LOD? So how much of the stormwater retention volume is calculated based off that LOD? And then delineating the drainage areas within that LOD and outside the LOD, right? So where is the adjacent area flowing to as well? Consider infiltration, right? So identify, are there any contamination hotspots or any other land uses there, you know, the fueling stations, that sort of thing. What are the soil types in the area? Do you have maybe good soil in the area that may have good infiltration, or do you have known poor infiltrating soils? Step 3, evaluating existing infrastructure constraints. So looking at and delineating these areas of potential conflict, the utilities, existing street trees, that sort of thing. Step 4, identifying the land conversion and BMP placement opportunities, right? So you can start thinking about where in this scope of what you've got at the 30% stage, where can you maybe do some land conversion? Where can you potentially put some BMP without having looked into detail of, you know, all the other items that you'll get into in later stages. But where could there be some potential? And you want to start thinking about that at this stage and showing it. And so let's take a look at a little example here. So 14th Street Northwest, there's this street project. So it's a type 1. They're going to be mostly doing mill and overlay, and then some of the adjacent sidewalk is going to be developed. So it's a little bit tough to tell on here, but you can see the LOD delineated, and I'll highlight it here on the next one. All right, so there is the limits of disturbance. It's mostly the sidewalk area there. As I mentioned, the mill and overlay is not part of the regulated stormwater volume. But they have the blue area here is all the drainage area, right? So as I mentioned, you have this drainage area that's within the LOD, that orange, and then you have the drainage area that's also flowing to it from the adjacent street. Some a little bit on the bottom here, some from, you know, just outside onto what might be the private parcel there. Oh no, sorry, it's still in the right of way. But it might be flowing from another sidewalk area that's outside of the LOD. As they've shown in this example here, this delineation of the drainage area is not considering the private areas that may be flowing. That's not always the case, right? So maybe this is, you know, commercial buildings that are right up to the right of way and there's no runoff coming from them. But in many cases, there will be runoff coming from these private parcels, and that should be included in the blue drainage area if that's the case, right? So it's really dictated by the actual site conditions. And then also in the right of way there, the existing, so this is the next after you've looked at your LOD, you've calculated the stormwater retention volume based on that, you've delineated your drainage areas, and then you show what the existing constraints are. So these are some existing street trees that are in the area, some utilities that are in the area, and you're showing this on your 30% plan submittal. Let me go over to the accompanying spreadsheet. So sorry for scrolling here. Just a moment, I'll get you where we need to be. All right, so I'll try to maximize this as much as possible, but the spreadsheet here, this is just a screenshot of the spreadsheet that you'll submit along with your 30% design phase. So the summary data, 30% design phase. You're going to be putting in these drainage areas, right? And you're going to be putting in information about each drainage area. So it's each drainage area, as I showed on the previous plan, you could see a little bit, I didn't point it out, but there were catch basins there, right? So each drainage area that's going to each catch basin, and what land is in each of those drainage areas. So there's the paved area within the LOD and paved area outside the LOD, right? So that blue drainage area and the orange was within the LOD, the blue was outside the LOD. So you're going to put those areas in there. The stormwater retention volume is calculated here for you based on the LOD within. And then this outside the LOD, this isn't included in your target, but it can be included in, you know, runoff available to treat, right? So it can get you towards your target if you're over treating that commingled volume from outside the LOD. Right? And then you're looking at some of the constraints and the site-specific details. So what is your hydrologic soil group, right? What hotspots are potentially available, right? You're looking at each of these drainage-based drainage areas and looking at the specifics of each one. Are you identifying any hotspots? And then the trees. So if you have, as I show, these existing trees, there's a stormwater retention value associated with that if you're able to preserve those trees. Right? And then possibility is there, you know, can I put a BMP? Can I do some land conversion in this drainage area? So the spreadsheet really walks you through these steps that I just showed on the previous slides, where it kind of takes you through drainage area by drainage area, identifying the land that you're considering, the drainage areas outside the disturbance, the infiltration potential or limitations, and then existing infrastructure constraints and potential for land conversion or BMP opportunities. And so you'll submit this along with your 30% design. Head back over to the presentation here. So then you'll go on to so you'll submit that. The plan reviewers will evaluate it and give you comments back to address before you move on to the 65% submittal. And it's really important, don't overlook this 30% phase, even though it seems like maybe, there's not as much detail on it. It's a really important part of the process to really get that, stormwater management as an integral part of the design thinking. So then if you address those comments, you move on to the 65% submittal phase. And so here are some of the sort of new items that will be considered in the 65% phase in addition to the 30%. So there's no real additional requirement from the 30% in terms of the drainage area and the regulated volumes, because you've already done that. It's not to say that your drainage areas are going to be exactly the same in the 65% phase as the 30%. They may change, right? Your design's going to change a little bit. So there may be changes in terms of your drainage area layout, but there's no new additional work that you have to demonstrate. You just have to update your spreadsheet, update your design. In terms of step 2, the infiltration, you'll have to actually go in and evaluate, right? Do your geotechnical testing, find where the water table is there bedrock, what's the infiltration capacity, right? So you're going to do some saturated hydraulic conductivity tests to see what the actual infiltration rates are at this stage. Evaluating existing infrastructure constraints. So there's not really anything, you should have identified these already in the 30%, the utilities, the trees, that sort of thing. But now in step 4, you're really going to start getting into drilling down into some of the specifics of the land conversion and the BMP placement opportunities. And then step 5, you'll actually start sizing the best management practices, looking at their contributing drainage areas, calculating how much retention you're getting based on the BMP sizing, the storage volume that you've sized it for, and then identifying where you're going to put some proposed trees, right? Where can you fit some new trees? So that's a new step in the 65% stage. So let's take a look at that on the same example project on 14th Street. So this orange that's shown here is land conversion, right? So there was some existing street trees, and then there was some existing pavement in between these 2 trees shown in the orange areas on the top side and the bottom side. So we can remove some of that pavement if it's not, needed in this particular instance. It's an opportunity for land conversion. You can reduce the required swerve, right? So if you're reducing the amount of imperviousness in your LOD, you're going to be decreasing how much, kind of your target. You're going to lower the target, which is helpful. So this land conversion area in orange is one opportunity. And then in purple here, we're showing some permeable pavements. So maybe there's some uses we need to have, access through these areas between the trees. That's a pavement, but we can put in a permeable pavement. It gives some additional stormwater retention capacity, helps out the trees with their rooting. It can help out, kind of modify the streetscape a little bit to make it a little bit more friendly to the uses, while a little bit more friendly to stormwater management, while also maintaining some of the uses of those spaces. And then once we've put a BMP in there, this permeable pavement, we want to delineate what is the drainage area going to these permeable pavements. So you can see there, the adjacent sidewalk area is graded into these different permeable pavements, in addition to the permeable pavement area itself, which receives rainfall. As I mentioned before, again, in this case, they're stopping this drainage delineation at the right-of-way line. That's not necessarily the case. It's specific to the project site, right? So if there are areas outside of that, they can be included in the drainage area if they're graded that way. Let me go over to the spreadsheet again. So this was the 30% design phase. So I'm going to scroll you down here. to the 65% design phase. And I'm going to give you an example spreadsheet in the activity later, so you'll be able to kind of poke around at the spreadsheet and get to understand it a little bit more in depth. It's a little bit hard, I realize, with these screenshots. But we're looking here. This is actually the left side of the screenshot, because at the 65% design phase, the spreadsheet gets a little bit more detailed, right? There are more steps, more details in each step. So you can see here in the step 1, drainage area and regulated volumes, there's nothing new, right? These areas may have changed based on your design, but there's nothing new to add in there. You just have to update it based on your design. Step 2, the infiltration, there's new information here, right? Before we were just looking at, is the hydrologic soil group amenable to infiltration, and is there a hotspot concern? Now we need to put in, what is the water table, right? Is it within the limits specified in the guidebook, which is that there needs to be a 2-foot space between the bottom of a bioretention or other BMP to the water table. Is there bedrock elevation? Okay, same thing there. What is the actual measured infiltration rate? So this is based on the geotechnical testing that you will have conducted at this point, and you need to put in the actual measured infiltration rate in this stage. This is one thing that we see oftentimes at this stage, that the geotechnical testing hasn't been done, or the infiltration rate that's shown here sometimes is just a filler value. So at this stage, what really the point of having this in here is that you want to be demonstrating this. You want to be testing it and seeing what that infiltration rate actually is. Step 3, existing the infrastructure constraints. This is the same as before. The trees haven't changed. So I'm going to scroll down, but this is, imagine we're going to the right here. So the right side of this, step 1, 2, 3, for these same drainage areas, we're now going to be going on to step 4, right? Just kind of imagine we carried on to the right there. So now this step 4, this is going to be a bit more detailed than we had before. We've got to identify the land conversion and the BMP placement opportunities, right? So we had 2 land conversion areas that I showed before in orange. So within our LOD, we can convert some of this pavement area to a landscaped area. We didn't have any bioretention opportunities identified, but we did have some permeable pavement opportunities identified. So you put the square footage, not of each permeable pavement area, but this is overall, it's lumped together for the drainage area, right? So the total permeable pavement area that was shown in those drainage areas, for each of those drainage areas. And then sizing and computing the achieved retention volume. So you're actually going to size your permeable pavement, right? How deep is your permeable pavement going to be? And then there are calculations that you can do based on the DOEE guidebook that shows the calculation methods. So how do you calculate the storage volume within that bioretention or that permeable pavement? And you can put that into the storage volume here, maximum storage volume, right? Cubic footage based on the sizing of your BMP. And then on the left side here, you have the drainage area, right? So you have this drainage area within the LOD and adjacent to the LOD. And so that is calculated the available runoff. So the runoff that we're kind of capping it at the 1.7-inch ceiling. So we're saying that, the intention of these BMPs is to treat up to the 1.7-inch storm. They're going to do, obviously perform some functions for larger storms as well, but we're capping this based on the retention value, assuming that some of the larger storm will bypass. So this calculation here, you're taking your drainage area that's going to the BMP, you're multiplying it by the 1.7-inch ceiling. So that's the volume that could be eligible to go into that BMP. And then we're comparing that against the maximum storage volume of the BMP. Excuse me. And so then the total maximum retention volume achievable is the sum of what the BMPs here are doing and the trees. So that's, these numbers don't add up because on the previous we had, 20 more cubic feet and 100 more cubic feet based on preserving these trees. So if we come down here, you can see I had 139 cubic feet of runoff volume that, I can treat up to that because that's what's coming to it, the permeable pavement based on the drainage area, plus the 20 cubic feet from the trees that I'm preserving gets me a retention value of 159 cubic feet. And then same thing down here, we have this 152 cubic feet ceiling for the available runoff, plus the 100 cubic feet of the trees gets you this stormwater retention value of 252 cubic feet. So you can see in both of these cases, there's more storage available in the BMP than there is runoff going to it. Not by that much, but so these are pretty well-sized BMPs. And then the final thing on this sheet here is they're comparing this overage or deficit, right? So comparing to that swerve that was calculated. So I'm going to scroll back up on the far left side. You had this swerve calculated in the LOD. So this is the target. This is what we're trying to get to. The 301, for example, here. And then 159 is what we actually retained. So then there's a difference there, and shown in red, that's the deficit. All right, so we're showing we're not achieving the full stormwater retention volume required for that drainage area, but through this process, we're demonstrating the maximum extent practicable, right? We're showing the constraints, we're showing where the BMPs are located, we're showing the sizing and the drainage areas that are available to get to those locations. And this kind of gives us a clear picture of how well did we do, right? How close did we get to that maximum extent? And, after accounting for the practical part of it. So let me take you back to the presentation here. Just going on to the 90% stage. So this is going to be, in many cases, not too different from the 65%, right? So the bulk of the stormwater management design should be in place at the 65%. And this is quite often the stage where you'll get the most comments or you'll have the most back and forth in the plan review process. So when you submit your 65% design, you're going to respond to those comments back and forth and address them before proceeding on to this 90% phase. All right, once you get to the 90% phase, there could still be some changes based on your design and the other things that are going on with your design process, and they can be updated and modified, but you should have the bulk of your kind of stormwater management approach laid out already and resolved to get to the 90% phase. So it's really going to be kind of a review check for compliance and maybe some of those designer initiated changes, as I mentioned. And let me see if I have a 90% example. I don't. Yeah, so that's the spreadsheet is basically the same as well. There we go. Okay, so the last thing I'm going to talk about before we'll have a little break actually before we get into our example activity. But some of the common things we see. Actually, let's go ahead and have our break first. Then we'll do our activity, and then we'll come back and do this kind of as a recap of some of the submittal challenges we see. So we've got 11:20 now. Let's go ahead and take a 10-minute break until 11:30, and then we can come back and we'll go over this activity together. Does that sound good, Morvarid?
Yes, just one more thing.
Yeah.
The practice, I was not able to attach in the group the practice, so I emailed the list of attendees that they register. If you have not received the email, please just send a message in the chat so I can resend it to you.
Excellent, thank you. Yeah, so everybody please check your email. We're going to go over some files that Morvarid shared. Yeah.
Yeah, actually, if you have not received it, Morvard is just going to put her email in the chat, and you can just send an email to Morvard, and she can reply to you to send the information.
Sure.
Yeah.
I'm gonna put my email here. So if you have not received anything from me, please let me know.
All
Okay.
right, so let's do a 10-minute break. We'll see everybody back at 11:30.
Thank you.
All right. hopefully everybody's had a chance to take a little break, and we have most people back with us. Everybody who is back, please go ahead and grab those files that were shared. We're going to go through the plan review activity just as an example for the type 1 MEP project. So I'll go through and just walk you through what the files are. And so we have this example plan. So one of the first files here you'll see, it's just a layout of this street. Just a JPEG file. And then you have a PDF of the same area. Landscape materials plan, and just two different sheets of the same layout. So you can see there's a match line. So you're showing this Missouri Avenue intersecting with Kennedy Street and 2nd Street. So this kind of triangle island here. And then the match line, we're just showing the one additional sheet at LS10. So this extending on down to Kennedy Street, some of the proposed improvements along Kennedy Street. So that's kind of the layout files that we're providing for you. Excuse me. The JPEG shows kind of the zoomed out version of what those two sheets on the PDF show. So everyone just take a moment to look through, make sure you have the files, and then kind of get familiar with this site. So you can see this Missouri Avenue, Kennedy Street, 2nd Street kind of triangle island that's being created, and this streetscape redevelopment. Right, so that's what this project is. It's sort of a streetscape redevelopment here at this three-way intersection. And then there's a design narrative also provided. So there's a Word document that has the design narrative. And so everybody please read through that design narrative. And you can see they've made some assumptions. They kind of give a description of the methodology, the drainage description, project description, that sort of thing. And then the final file, the fourth file that's shared here, is the DDOT MEP worksheet, right? So this is just look at the 65% phase. Don't worry about the 30 or the 90% phase. We're just going to look at this as if we were looking at a 65% plan submittal for this project. And so you can see here they've identified the drainage areas and put in some of the information specific to this Kennedy Street Northwest improvement. And so what we're going to do in this exercise, hopefully everybody's back. Does anybody have any issues? Looks like everybody got their access to the files resolved. So what we want to do here is go through these files. So take some time here. We'll have as much time as we need, but let's say we'll go through this in about 15 minutes or so. We'll give you to review the design narrative, read through it, see what this design is all about, the layout files, and then the MEP worksheet. And go through as if you were a plan reviewer or maybe a senior engineer reviewing this project from a junior engineer's design, and try to think with all the things that we've talked about today, all of the possible points of error, all of the BMP considerations that we discussed. Look at this with a critical eye to see what comments a plan reviewer might point out, and what you might receive back from the DOEE or the DDOT plan reviewer when you've submitted this. So go ahead and everyone take the time to read this and take a look at the layouts. I'll stop sharing my screen Maybe I'll go back to the presentation. But everybody go ahead and read through and kind of start formulating your comments. And then as you come up with comments, throw them in the chat. So we'll go through and we'll discuss what everybody finds. If you have any questions, go ahead and throw those in the chat on this. And anybody who's, as you identify anything you see in the narrative, anything you see in the plans or in the spreadsheet, I know it takes a little bit to familiarize yourself with all these documents, but anything you see that pops out to you, go ahead and throw it up in the chat. We'll give it just 2 more minutes. Anybody who wants to throw it, whatever comments you have in the chat, we'll walk through it together, sheet by sheet, and go over some of the comments I have. But please feel free to put your own into the chat. All right, so let's walk through the maybe the narrative first. Let me pull this up. So let's look at the design narrative. So this report is prepared to illustrate the design of stormwater drainage system along Kennedy Street between Georgia Avenue and North Capitol Street, right? So there's this 3-way intersection. It involves an intersection improvement, Kennedy Street revitalization plan, about a mile-long stretch, trying to improve the overall image of the corridor. Consists of pavement resurfacing and sidewalk improvement, curb and gutter replacement, and intersection improvement, and bicycle lane and streetscape improvement. They describe the drainage within the project limits, so runoff under the current conditions. Kennedy Street flows towards the 2 low points, one located at the intersection of 4th Street and one at 9th Street. The high point is between 8th and 9th Street. Drainage pattern in the proposed conditions are essentially the same, except at the locations of the proposed bioretention areas in the islands. So there's some proposed bioretention at that intersection area. The methodology, they've used the catch basins. The contributing area for each catch basin is the impervious areas of the roadway and the immediate adjacent sidewalk. Sidewalks are excluded from the drainage area where sidewalk is separated from the roadway by a continuous grass space. And then they've used the rational formula constant coefficient of 0.9 assumed for discharge computations, since the existing land use in the developed area is urban lands, primarily impervious surface. The assumptions that they have down here, one is that the study only considers drainage areas up to the adjacent intersections that have stormwater flowing into the project site. It only considers stormwater generated within the public right and outside. Subtracting sidewalks, it is assumed that the natural cover is 90% of the total area, right? So 90% of the total area is natural cover. So does anybody see anything in this design narrative that jumps out to them that maybe needs to be corrected? So when I see looking at assumption number 1, so they're only considering drainage areas up to the adjacent intersection that have stormwater flowing into the project site. So that's not an assumption we want to make, right? So there are intersections within the project LOD, but they should have the drainage areas mapped and include stormwater calculations, right? So they've only, let me show you on the see the drainage. This is, I believe the JPEG shows us this. All right, so you can see these drainage area delineations in the JPEG here. So they're delineating the area to these catch basins, right? And so there's this drainage area, for example, here on Kennedy Street, that's showing this drainage area kind of flowing into this catch basin. But, you know, there's drainage area also outside of this that's within the LOD, right? So they are not including these drainage areas because they flow outside of the LOD. You have to consider those drainage areas as well in those intersections, right? It's within the LOD, so it has to be considered. Assumption number 2, they've assumed that the drainage area stops at the right of way, right? So in some of those cases, they you have to consider what's on the additional area if the site conditions warrant it, right? So you can't just stop arbitrarily as assuming that there's no drainage beyond the right of way area. And then the third assumption was that let me bring it back up. Third assumption was that the outside the LOD area, it's assumed that it's natural cover, that 90% of the area is natural cover. Since this is an urban residential neighborhood in this area, a more accurate assumption would to be that it's 90% impervious and 10% compacted, or something closer to that. Right? It doesn't make sense to assume that it's 90% natural or even compacted cover, because there are buildings, there are all sorts of things outside there. So there's a couple things that stand out with the assumptions. Methodology. So they've excluded the sidewalks from the drainage area where it's separated from the roadway by a continuous grass space. That's not a good assumption, right? Because that sidewalk drainage is going to go somewhere. It's probably going to go into the roadway. So the sidewalk area should not be excluded from the drainage area. And then the runoff coefficient, so they've used this rational formula coefficient of 0.9 for discharge computations. The calculations that the spreadsheet uses and the calculations that are detailed in the DOEE Stormwater Management Guidebook, the swerve and the runoff are calculated based on a specific formulas. And so the coefficient for impervious surface in those calculations is actually 0.95. And so this is, sometimes we'll see people use the rational coefficient of 0.9, but you have to use the coefficients that are included in the calculations in the guidebook. Okay, so we've got a comment here from Ashley Greer that seeing the proposed brick sidewalk, and then would it be possible to use flexible porous pavement as a better option? So that's a good point. So let's look at the drainage, the landscape materials plan. So you're seeing here, there's this brick sidewalk. It's a little hard to see, I'm sure, but you're looking at this on your computer, so you see this brick hatching. There's quite a few areas here where there's brick sidewalk proposed, especially between these trees. They have flexible porous pavement on here. I don't see where they're proposing it, but that's a great point, right? Is there opportunities to put that permeable, that flexible porous pavement or some other permeable pavement, particularly in these strips between the trees, right? So all this area here is a brick sidewalk. Yes, go ahead, Julie.
Yeah, I'm going to slightly alter that, but so flexible porous pavement, you know, that's that rubber pavement that really only should be used to support trees, primarily existing trees. But they could still use a permeable pavement, like a permeable brick paver that would match the rest of the sidewalk, but would be permeable. So we're going to look for that porous rubber flexible pavement in very specific applications versus a permeable pavement might be more appropriate for all those new tree plantings in the tree strip.
Excellent point. Thank you. Yeah, so you can see that opportunity here to have a different type, you know, permeable brick paver. Whereas, yeah, I'd found that there's that one spot where they have the flexible porous pavement around this one tree here. Thank you, Ashley, for contributing that. Let's look at the JPEG here. So we're looking at the drainage plan on this one. I'll zoom in a little bit so we can see. So you can see they've delineated these drainage areas, and they've put drainage area equals the area, and they've got the catch basin labeled. But there's some other information we'd like to have on this. So, where is the right of way? Right? They talked about the drainage stopping at the right of way line, but we need to see on the plan somewhere where that right of way line is. Where is the LOD? Right, so we need to be able to see those in relation to the drainage delineation, and some of this might be done on different sheets, but just kind of important things to think about here. What type of land cover are we looking at? What part of this is impervious and what part of this is compacted cover? There's also a drainage area missing here. So there's, this bioretention that's proposed here has a curb cut. There's some drainage area that's going to be going to it, but it's not delineated and labeled on here. And then labels as well, right? So labeling these drainage areas, labeling the bioretention itself, the BMP that's proposed. Let's take a look over at the plans again and see, again, labels, right? So the labeling of the drainage areas, the catch basins, the bioretention, identifying the trees and species, right? So there's an existing tree to remain. Somewhere on the plans may not be on the same plan because this is the materials plan, but you may have somewhere on the plan you'll need to say what type of tree this is. You're also, when you're proposing a tree, need to think about the rootable soil volume. So for these proposed trees, you have to show somewhere that you're providing sufficient rootable soil volume for that tree, whether it be through, the actual turf or landscaped areas, or whether you're supplementing it with that structural soil. And so you'll have to have some plan demonstrating that you have sufficient soil volume available to the trees that you're proposing. And then another thing that we just mentioned was, are there opportunities for more permeable pavement? So there was multiple areas in here where this brick paver could be replaced by some permeable brick pavements. Let's see here. Let's take a look over at the spreadsheet. So a few things to see on here. So they have the different catch basins used as their drainage area IDs. They've input the areas within and outside the LOD. The swerve is calculated here based on those areas. They've put in the infiltration considerations, right? So what type of land or soil group, water table, bedrock, infiltration rate. One thing that jumps out to me here on this infiltration rate, every single drainage area has the exact same infiltration rate. So what that tells me is that they did not do actually geotechnical testing. They just plugged in the 0.52 inches per hour. So that would be something that would get flagged by the reviewer to provide the actual field verified infiltration rate. They have the trees in here, the volumes calculated associated with it. Some land conversion opportunities are put in, permeable pavement opportunities. And then we have the drainage areas to the bioretention, maximum storage volume, the bioretention. So we'd need to see, so these calculations here, the storage volume calculation, it's done somewhere else. It needs to be provided. It's not in these files that I've shared here, but it needs to be provided in your plan set so you can back up, where did that 350 cubic feet of storage volume come from? And I think it doesn't look like they have it at all for the permeable pavement. So that's something to think about. So you're putting in the storage volume in this spreadsheet, but you need to demonstrate the calculation and show where that came from. I see a question in the chat about how involved is geotechnical testing? What's the turnaround time and what kind of technician can perform? So there are specific geotechnical testing procedures outlined in the Stormwater Management Guidebook. I can't remember which appendix it is.
P as in Paul.
P as in Paul, thank you. As far as how, what the turnaround time and what kind of, you know, how involved it is, I'm not entirely sure on that. And if Melifon, you have a sense of that from your time in the consulting industry, or Julie?
Yeah, I can add some. Karen, it's really going to depend on your consultant, but essentially this would be a subcontractor to your design or CM consultant, and then you know, depending on how many tests you have or what their schedule is, they can usually do several tests in a day. It just really depends on how much you're going to pay and like their schedule and everything. But it varies across different firms that you have.
So there's there are kind of multiple components to it. To further up on your question there about the soil sample, so it's going to be giving you information about what the soil profile is, and then also doing a saturated hydraulic conductivity test. So they're going to be actually putting in a test instrument where they, you know, essentially pour water into a cylinder and see how long it takes to infiltrate. There's specific, you know, steps to it and guidelines around it, but those are the two key things. So they'll do actually a boring down into the ground. They'll take a soil sample from that, and then they'll do the infiltration testing as well. And then you'll get a report back showing what your soil profile is in a narrative form, and then they'll also have the you know, some sheets showing the soil horizons and then showing the calculations of that saturated hydraulic conductivity. Excellent. Does anybody have any other questions or thoughts, anything else that stood out to them on this design example? Yeah, so Ashley Greer pointed out again that where did they get the natural square footage information from? So that's, yeah, a great point, is that it doesn't seem to be reflective of the numbers in the city area. And so that's not a great assumption to assume that there's that much natural area outside of your project area. It looks like, oh, so is soil testing for every subcatchment? I believe that's the case. Is that, I can confirm, Julie, that we do require a geotechnical testing for each catchment?
So it's going to be based on your proposed BMPs. And reading Appendix P is really the best way to go. But so essentially, if your BMPs are spread out, then you might need one per BMP. There's also a square footage requirement. So like we have green alleys. So depending on the size of the alley square footage, that might require multiple testing for that one facility. And then also if you have, you know, a number of BMPs all within a certain radius that is described in table P1, then you can group some facilities and just do one test for multiple facilities. So Appendix P is really where all of those questions are, but it's based on BMP, not necessarily each subcatchment.
Yeah, so that's a good point here. So if you've got a subcatchment here, a drainage area where you don't have any BMP opportunities, you don't need to look into the infiltration for it. But if you're considering it, if there's, you know, there's some other reason why it's conflicted out, you wouldn't have to worry about it.
There's one more question from Jeff.
The coefficient of 0.9, does the calculation sheet apply the same coefficient in the sort of calculation? And don't believe that's the case. I'm trying to see here. Actually, yeah, the spreadsheet does use the 0.9 coefficient. It's a good catch. I don't know. I suppose the calculation there is sort of a rough calculation, right? It's sort of an approximation because we don't have the same formula that's in the guidebook. We're just taking the area and assuming a 0.9 coefficient.
That looks like a formula, and so I think it might be partly because they're putting in information that is wrong, but it's calculated.
Yeah, that's what I'm thinking. I should look into what the raw spreadsheet looks like. Does the normal calculation use the same?
It uses the
calculation
0.25 and 0.95. Yeah,
okay.
It uses the correct coefficient. So I mean, I think it's just a nature of kind of like where you are with this spreadsheet, but it wouldn't necessarily be the same for everything because it's a formula.
Okay, so this looks like a formula that's been modified here. So they created this runoff coefficient modified based on their assumption. So yeah, the normal calculation would be a formula in here based on the DOEE stormwater management guidebook calculation method. Water quality catch basins. Are they considered in the spreadsheet? And they're not in the spreadsheet explicitly. You would have the drainage area delineated, but there's not a place to input them in here. But you would show that on your plans. You focused, next question, you focused mostly on stormwater quantity, but how is quality addressed? On-site treatment always required, and do you have to find an equivalent total phosphorus load for each project? So it's a good question about the quantity and quality. So what we do, the approach in DC is sort of a retention based. So we are using this idea that if you're retaining the stormwater in a BMP, the quantity and quality are addressed. So you get the stormwater into a permeable pavement, into a bioretention. You don't have to do a calculation on the phosphorus load or anything like that. You just calculate the volume that's being treated and managed by that. And that handles that sort of quantity as a proxy for quality, if that's clear. Let me go ahead and pause here on the questions. I want to make sure that Morvarid has time to go over her examples, or sorry, her slides, and some of these questions may actually be answered in her section. So I'll go ahead and hand it off.
Thank you so much. I'm going to share my screen, but before that, I think I'm going to introduce also my team. Julie and I both are working with Green Infrastructure DDOT team, and we have our own DDOT projects. We're also reviewers, so you may know us either as a project manager for Green Infrastructure projects or reviewer for other projects. But thank you so much for staying here. My presentation will be much shorter. Right now, I'm going over just a couple items that, as part of DDOT's review, when we are reviewing stormwater management plans and calculations for the projects. There are some items that I'm going over based on the reviews that we had recently for the projects that we've been doing, and these are based on experience and that happened recently in our reviews. I'm going to go over stormwater management for the projects that have existing and proposed right away. Then I'm going to go over the guidance in applying DDOT standards, the common question of what is a disturbance, and then what you need to submit to DDOT for stormwater management review. So stormwater management for sites with existing and proposed right-of-way. Stormwater management requirement can be different based on the nature of the project. Yes.
I'm sorry, can you just show the presentation so we can see the slide full screen?
Oh, sorry. Oops, nope. 1 second. Escape. Is that better? 1 second. Is that better? Yeah. Sorry about that. I guess this is better now. Okay. So I'm gonna go over first DDOT project with proposed right of way, and then roadway dedication projects. DDOT projects is sometimes we are doing our capital improvement projects, for example, as part of DDOT, and then the purpose and the need of the project needs the project needs a parcel to be transferred to DDOT to meet the purpose of the project. As an example, for example, SATCAP is one of the DDOT projects that we needed to transfer some parcels to DDOT to provide that oval that you can see now in Southeast DC. So when we are transferring a parcel to DDOT, this is a type of a project that you are required to meet full regulations instead of just MEP. But there's another type of projects that we are transferring the publicly owned land like MPS to DDOT or to DC. That can go under MEP or full regulations. It depends. If it depends on the nature of the project. If you're transferring, for example, publicly owned MPS or MPS land that is already a road to DDOT, that can follow under MEP, or if it's just parcel or grass by MPS to DDOT, that can go on fall under full regulations. So it depends on the nature of the project, but when you usually transfer a parcel to DDOT, it goes under full regulations. These coordination should happen should be through DOEE, and DOEE is the agency at the end decide which which part need to go under MEP or full regulations. The other example for existing or proposed right-of-way is roadway dedication projects. Those projects are the ones that we are transferring a parcel to DDOT after construction. The picture you see on the right, this one is one of the examples of developer projects. It's basically, it's called Park Morton. It came through developments, and we are transferring a private parcel to DDOT. So so this part of the project is in right-of-way, so it's existing right-of-way. So that part includes MEP, but the part that is being transferred to the parcel that is being transferred to DDOT will follow full regulations. So I said all this story to say, when we are reviewing these types of projects, we need a stormwater management report that has a comprehensive narrative to help us to understand the needs and the purpose of the project and apply appropriate rules and regulations accordingly. I said that mostly because I know that there are so many projects that come to us in DDOT Green Infrastructure team that we ask for report, and they think because it's a developer project, it's a DDOT project, they don't need to provide a report. Report is always necessary for us to understand how to proceed further. So another thing that we usually see that's in our projects that we need to coordinate with the PM or developers or any types of projects that comes to us is applying some of the standards in the bioretentions. So there are some of these standards has not been updated in our DEM or green infrastructure standards. So we thought that it's good to bring it up here in this slide. The first thing is is about the width of the bioretention. So based on the recent coordination that we have with Urban Forestry Division / UFD, we are recommended to have a wider width for the bioretention that includes trees. So if the minimum requirement for the width for the bioretention based on green infrastructure standards is 4 feet, if you're proposing a tree in, then the width should be 5.5 or 6 feet for the bioretention. So when you're laying out to have to propose a bioretention, you may be challenged because we do not have enough space. It's an urban environment to provide a 6 feet bioretention to propose a tree. What we recommend is we are trying to have a combination of both. So you can always have the trees at grade and bioretention combination in one street. You can also propose your bioretention as a curb extension within the parking space to meet enough width requirements. Sorry. So the other thing that we also were recommended by UFT is you have to request us to request full depth check down 10 feet away from the center line of the tree. This is another requirement. As I mentioned, you have to use a combination of street trees at grade and in bioretention, or utilize other areas for bioretention in the parking lane. One thing I forgot to mention for the first one for the width is we also ask what's the reason why we need to have a wider width for the bioretention when we are having a tree. It's not only for the planting, but we also for the future maintenance because the tree keeps growing and we don't have enough space for the future maintenance if we still keep the width of the bioretention with the tree as 4 feet minimum. The other standard that we still have it in our green infrastructure standard, but we stop using is fences around the bioretention is this one. I forgot it's 621. I wish I had my GI standard open, but it's L-wall standards. We have two types: is L-wall flush and L-wall with reveal. We only use L-wall with reveal. We stop using ornamental fences or fences around the bioretention. And we will keep this standards because we still have bioretentions with fences in the green infrastructure standards, but we are not going to use it further due to some maintenance issues. So this is the three standards that I wanted to mention as part of this presentation. There is another, there are two more that we need to mention. One is we are no longer using rock check dam. This is based on the three that I mentioned is green infrastructure DDOT standards. These two is for other agencies. The first one is for DOEE. Rock check dams are no longer in use for ponding per DOE guidelines. So you can use other materials such as concrete, plastic, lumber, etc., to achieve your ponding in the bioretention. So we also we have our requirements for utilities in green infrastructure standards, but we also recommend to follow utility protection guidelines or for their own guidelines, utility guidelines besides DEM and green infrastructure standards. For example, DC Water has its own utility guideline, protection guideline for green infrastructure that we always ask designers to also use this one, specifically for DC Water, and not just use DEM or GI standards. Last but not least, actually two more left, is about the disturbance. I think that was the common question that we had when also Travis was presenting. Disturbance is based on the DOEE definition is the movement of earth, land, or sediment that disturbs the land surface and the related use of previous land to support that movement. So that means I put some examples. We put some examples of what is a disturbance and what does it is not a disturbance, and comparing these two can help you to understand the definition of disturbance. For example, when you're doing the full depth pavement, you are per definition, you are disturbing the land surface and related use of the previous land. So that's considered as a disturbance. If you do any staging or temporary construction entrances on the vegetated area or natural areas, you are disturbing the land, and it's not the same and the use of the previous land. If you're proposing a new sidewalk, that's also a disturbance. If you're proposing a median or bump out and disturbing the base, that considered as a disturbance. What is not a disturbance? Mill and overlay, bridge deck rehabilitation, utility trenching, alley rehabilitation, and median or bump outs that are not replacing the base. So I was actually just thinking about the utility trenching. For example, if we are reviewing a construction in DC in the private property and they are coming to the right of way and only for utility trenching, that is not a disturbance. But if we are doing a work in a right of way, for example, capital improvement project, and then you're having a utility trenching in the half of the road, that will be considered as a disturbance. So it depends on the nature of the project and where it's happening. DC block has a lot of utility trenching. That is not considered as a disturbance. As usually Julie also mentioned, I'm going to emphasize on that. Do not avoid replacing the base to avoid stormwater management if it's needed. I don't want the designer to focus on proposing a median or bump out on the base, on the existing base, and not replacing the base so they can avoid the stormwater management calculations and MEP and all the other permitting that we need. I hope that I covered this well, but we can also answer more questions if it's needed. Submissions. So this is the last topic that I'm going to cover, and then we're going to answer any questions after. So all DDOT projects, including road dedication projects, are required to submit the stormwater management and drainage checklist to DDOT. We provided this stormwater management checklist a couple years ago. It helps us to follow the requirements that we need or the documents that we need for our review. I'm emphasizing all DDOT project, including road dedications and other teams that are providing documents for us to review, are required to submit the stormwater management checklist. And if you're missing a document, if you're submitting 30%, and I'm checking this stormwater checklist, and then you guys missing an item, we are returning your submission. We are not moving forward with the review till you submit the completed package. Stormwater management and drainage reports. As part of this also submission, you need to provide a narrative and your appendices that includes calculations and maps. So everything per DEM or your plan sheets should be in scale 20, but drainage area maps should not be submitted in 20 scale. Also, that should be under your maps. You don't need to, the map provided are separated from proposed plan sheets and showing the stormwater management elements. Also, stormwater management map must include all required information for MEP, and it should not be on a scale 20, but maybe you need multiple maps to show all the information for MEP as well as the entire contributing drainage area at a reasonable scale. So we don't need to see the drainage area map in 10 sheets. It can be in different scale, not just one sheet. You can have it in 2 or 3, but you don't need to submit it in a 20 scale. I think I covered everything. We still have 10 more minutes. So if you guys have any question, I can answer.
Can I add one clarification on the disturbance for utility trenching?
Yes, sure. Let me share my screen.
The utility trenching is considered disturbance for erosion sediment control plan. So whenever you're submitting to DOEE, you are required to provide erosion sediment control plan for the disturbance due to utility trenching, but it is exempt from the stormwater management.
Thank you. Julie, you're asked about the copy of the checklist. Yes, we can send a copy of DDOT HNet checklist. I can send it to the the same as the other document that I emailed. I can email also the checklist.
Yeah, we can send that at the end of the training. This is something that we've been also providing at like 30% or 65%. So we try and provide it even at kickoff for design plans for DDOT projects. And so that's something to look out for, because if we do update the checklist or anything, getting it at the beginning of your design project, it will make sure that you have the most correct version of it.
I'll share here. I have one more slide. It kind of building off of that, the submittal challenges we see sometimes from DOEE, that 30, 65, 90%, it's really key to follow that process. Don't submit the 90% as your first submittal. It's one thing we see happen, and it really slows down the process. Other things we see, infiltration testing not considered, areas inside and outside the LOD. Someone asked about water quality catch basins, right? So where there are drainage areas that don't have other BMPs, you can put those water quality catch basins in. It's not in the spreadsheet as we mentioned, but it should be in your design. And then some other things we see that you can really use the DOEE Stormwater Management Guidebook to help you clarify the difference between a site drainage area and a contributing drainage area. I won't get into that, but just take a look through the guidebook that'll really help you on that. And then using the surface and groundwater system, the SGS, we have a training available online also on just the basics of using that. I believe the link was shared to the trainings before, so it's on there as well for questions about how to manage that system.
Thanks for mentioning also the 30%, 65, and 90%. Please submit all your submissions to DOE. We usually get notification that some projects have not been submitted till 90% to DOE. Try to always be parallel. We are trying to have our reviews parallel with DOEE. There are so many cases that DOE approved. We're trying to be parallel and coordinate, but sometimes DOE approve and then we have comments, and the consultants or other PMs think that, oh, they have to go back to DOE and resubmit it to the database. Make sure that when you're submitting for DDOT review, we also at the same time submit to the DOE so we can have a parallel review with each other, so you don't have the stamp and then go back and resubmit after DOE approval. One more question. So no fences around bioretention planters or any BMPs. Isn't there a safety issue, risk of a person stepping down, or is there? So when we do the flush, I can share my screen.
Yeah, I added to that. There is a curb that's always required. And there will be some instances where we do see the fence, but we have just found that it is a big maintenance issue. They often get hit. They often then end up being hazards to pedestrians and other folks. And so we do not want to see fences anywhere close to where a car would, so not adjacent to travel lanes, not adjacent to parking lanes. And they are used only, again, with like specific. So that would be the exception. Generally, we want to see the L wall with reveal, which is on the right.
So that, as you can see, that 4 inches is kind of for the safety, instead of having it flush and then the fence.
And that fence is only 18 inches high. It's not, these are for facilities that have an 18-inch drop. And if there is a larger drop, if you look at our design and engineering manual, it will talk about, a much higher fence if there's a significant drop off between the sidewalk elevation and the bioretention.
Okay. I don't think there's any more question. That's good. We were on time. Travis, do you want to wrap it up?
Excellent. So thank you everyone for attending. Really appreciate. If you have any follow-on questions, please reach out to Morvaid shared her email. I'll put my email right now in the chat. So please, follow up questions. And as Melifon mentioned earlier, you can always reach out to your plan reviewer when you're in a project and do that PDRM process to get your information, your answers question. There's Melifon's email as well. So that's a good contact for the DOEE side. But appreciate all of your attention, and hopefully you learned something today, and so I'll help you out in your plan development process.
Thanks. Thanks, everybody. Enjoy the rest of your day.
All right. Take care, everyone.
Thank you, everybody.